In this video series, I worked through a math problem each video. We were given various algebraic expressions in this problem. The directions are to combine like terms and simplify the given expressions when we can. Terms consist of the number part, called the coefficient, and the variable part, which are multiplied together. In the algebraic expressions presented in these problems, these terms are added or subtracted together. We can combine multiple terms together when all the terms have the same variable part. This includes the exponents for each variable in the terms. Let's look at the first problem. We have 5x plus 3x. Both of these terms have the same variable part, which is x, so we can go ahead and add the coefficients or the numerical part of each expressions together. So we get 5 plus 3 quantity multiplied by x, and that's equal to 8 multiplied by x. Next, we have 2m plus 3y. If we compare both terms, 2m and 3y, they don't have the same variable part, m and y. So we can't combine these terms together, and we need to just go ahead and leave the expression in this form. Next, we have 4x plus 8x plus 2y. Here we have three terms, 4x, 8x, and 2y. If we look at the variable parts for each of the terms, we have x, x, and y. Since the first two terms share the same variable part, we can combine them together. So we get 4 plus 8 multiplied by x, and we need to leave 2y as is since we can't combine it with either of the first two terms. 4 plus 8 is equal to 12, so we get 12x plus 2y. Next, we have k plus 2k. The two terms we have here are k and 2k. They both have the same variable part, k, but k doesn't have a number in front of it. We can think of that term as having 1 multiplied by it. So we can actually rewrite this as 1 multiplied by k plus 2k. Now we can go ahead and factor out the numerical part from both terms. We get 1 plus 2 multiplied by the common variable k, and we get 3k. Next, we have 5j plus 3j plus 7j. We have three terms, 5j, 3j, and 7j. They all share a common variable j. Though we have three terms, we can go ahead and combine all the numbers together. So we get 5 plus 3 plus 7 multiplied by j. 5 plus 3 is 8, and 8 plus 7 is 15. So we end up with 15j. Next, we have 6mp plus 5mp. The two terms are 6mp and 5mp. We have two variables multiplied together for each term, but they're still both the same, mp. So we can combine these terms together. We add the numerical parts together, 6 and 5. Then multiply that by the common variables. So we'll multiply this by mp. 6 plus 5 is 11, so we get 11 mp. Next, we have 9x squared plus 7x squared. The two terms are 9x squared and 7x squared, and the variable part is x squared and x squared. They both have the same exponent. They both share the same variable x, and both of these variables have the same exponent of 2. So we can combine these terms together. We calculate 9 plus 7 first, and then multiply that by x squared. This is equal to 9 plus 7, which is 16, multiplied by x squared. Next, we have 3x and 10x squared added together. The two terms are 3x and 10x squared. Even though both of these two terms have x in common, the first term has just x, and we can think of x as just x to the first power. So if we compare the exponents of these two terms, the first term has an exponent of 1, and the second term has an exponent of 2. Since these exponents are different, we can't combine these two terms together. So we'll go ahead and leave 3x plus 10x squared in this form. Next, we have 7ab plus 3ba. The two terms are 7ab and 3ba. If we compare the variable parts for these two terms, we have ab and ba. You might notice that they both share the same letters, but they're in different orders. One of the properties of real numbers is that we can rearrange any numbers or variables multiplied together, and it's called the commutative property of multiplication. We can use that to rearrange the variables. So when we're working these problems, it's a good idea to take the variables and rewrite them in alphabetical order. That way, we can compare the terms to see if they're like terms or not. So if we go ahead and do that, the first term 7ab has the variable part already in alphabetical order, but the second term has the variable part out of alphabetical order, so we can rearrange the variable part, which gives us 3ab. Now if we compare the variable part, ab and ab are the same, so we can go ahead and combine the numerical part, 7 plus 3, and multiply that by ab. This gives us 10ab. Next, we have the sum of 1/5 c and 3/5 c. The terms have a common variable part c. The only difference is here we have fractions for the coefficients as opposed to integers that we've been working with so far. But when we are working with terms like these, all we care about is that we have the variable part and the numerical part. So it doesn't matter that we have fractions. We can just go ahead and treat each of the coefficients as we've been doing before. Since we can combine these terms together, we'll add the numerical parts together like this and multiply that by the common variable, which is c. 1/5 plus 3/5 is equal to 4/5. So we get 4/5 multiplied by c. Next, we have 3ab plus 2a squared b plus 4ba. Once again, let's go ahead and rearrange all the terms so that all the variable parts are in alphabetical order. If we do that, we get 3ab plus 2a squared b plus 4ab. Now if we compare the variable parts for all three terms, we see that the second term has a power of 2 for a, but neither the first nor the third term share that exponent, so we can't combine the second term with anything else. But the first term and the third term both have a variable part of ab, so we can combine the first and the third terms together. So we get 3 plus 4 multiplied by ab, and we can add 2a squared b to that. Three plus 4 equals 7, so we get 7ab plus 2a squared b. Finally, we have 5d minus 2d. The only difference is for this expression compared to previous expressions is that we have a minus sign instead of a plus sign in between the terms. But if we look at both terms, they share the same variable part, d. So we can combine the numerical parts just like we've been doing earlier. The only difference is we're going to be subtracting because we have a subtraction sign between the two terms. So we work out 5 minus 2 and multiply that by d. And we get 3d.